So pressure piping, we continue on with pressure piping, section 300 KF in 2018. They're saying, they have a statement, they're saying for high pressure piping, you can use chapter 9 is an alternative to the rules that we discussed about in chapters 1 to 4, which is, the design, the materials, and so on. And basically, when you really dig deep into the specs, you go and find what high pressure piping is, and basically it's generally defined as ASME class 2500 or higher. So they start off by in K302 by the definitions. Recall that 300.2 is in chapter 1. But basically, they're saying, 302 is exactly as 302.k, except for the fact for terms relating only to non-metals and severe cyclic conditions. So if you have the cyclic conditions, then the definition does change. But in there, they use allowable stresses are used in terms of in lieu of basic allowable stresses. So let's look at 304.8 fatigue analysis. So when do we do this? What are the exceptions? 304.82 says suitability fatigue analysis, exceptions to the evaluation. Okay, so maybe there's some exceptions we can avoid the extensive work required. So when we have a equipment that's duplicate or a similar operating history, we don't need to do a fatigue analysis. If we have calculations that are very similar that have shown that it works, then we can use those calculations. ASME allows that. On with this 304.8. So they talk about amplitude of alternate stress. Remember, we talked about if the amplitudes get higher and higher, and if they're not fully reversing, then and they don't, they could be an issue. So this is what they say. So you're allowed to go into the boiler pressure code, section 8, division 2, and use the rules there. In particular, the design curve for part 2, paragraph 315. And this hasn't changed in the last few years. So my reference point is 2018. And they want you to follow, part 5 for the analysis. Or alternatively, you can use section 8, division 3, article KD2, which I'm not familiar with, but I am quite familiar with division 2. The alternate considerations, you can use K302.1, but be aware there's a lot of precautions there. Going back to division 3, that's the higher pressure one, and we did some videos about when to use division 2 and division 3 and what the issues are associated with that. So anyways, we'll continue. So we are going into pressure stress evaluation for fatigue analysis. Straight piping, the stress intensity calculation, this is the calculation that can be used. And, it's a modification of, your standard hoop stress equation, right? And then the stress intensity, you'd follow the as boiler pressure vessel code, section 8, division 3 for, stress intensities. The fatigue evaluation by test is an option. And the fatigue life of a component may be established by, DE and in lieu of analysis. So destructive evaluation is what I mean by DE. And so, but you must follow the criterion for K304 7.2. So this is where you would get a lab involved and build components and then run them under cycles if it's a complicated design. And this is a pressure design of components. So we continue 304.8.5 extended fatigue life. It's extended by ASME B, boiler pressure vessel code, section 8, division 2, follow part 5, allowable design curve part 2, 315. You can go and use section 8, division 3, article K2D. You can extend the life by following 304.7.2 qualifications and surface treatments to improve the surface finish. And of course, the smoother the surface, the less chance of there being reducing the nucleation sites where cracks can begin, the stage 1 cracks. Pre-stressing components is a strategy. Auto-fretted shot peening, so you're basically increasing the hardness of the surface, and you only want to do it at that surface, so that to reduce the chance of a nucleation site happening for a crack. When in the inside of the component, as we talked about in earlier videos, you want your material to have a high toughness, but the surface you would like to have a very hard surface. Note that the pre-stressed surface treatments may be reduced due to thermal straining or softening. So you have to look at your application and evaluate whether your surface hardening will be able to handle the type of surface you're in. So Appendix D intensity factors. So we have 319.3.4 allowable stresses refers to Appendix D. So this table D1, flexibility analysis and intensity factors. This has been done for a long time, but I should note that in the 2020 edition, this was all moved. The standard tables that were used since time immemorial of B31.3 were basically removed, and basically you just go to ASME B31J in the 2020 edition. But if you're analyzing existing piping, 2018 and earlier, then I believe you're still allowed to use the Appendix D. And here's an example of, your table D1 and an elbow. And this is, still, in use in the other codes like B31.1. And so, but take a look at that. And, we have other videos about this, stress intensification factors as well. Appendix flexibility analysis. So welds to socket welded fittings, the stress intensification factor. So they really want you to follow certain geometry factors and weld sizes to avoid potential fatigue. And say for example over here you can see gap requirements and then certain size requirements. And you notice that the size of the legs of the weld are exactly the same. And so there's very specific requirements for socket welding to reduce stress intensification factors, which promote fatigue and cracking. So the next thing is welds to socket jointed flanges, and they want you to follow the criterion shown in 328.5 to be, and this is in part to reduce the effects of cracking. And again, we're over here and we have a gap shown so that when we thermally expand, we don't put stress on the welds. And so those are the criterion that kind of rules of thumb to avoid stress intensification factors. And I mean there's more to it too as well, like grinding your welds and making sure they're smooth is also a great way to reduce fatigue, to chances of fatigue. So Appendix F has some guidance and precautionary considerations. So refer to Chapter 2 for F301.10 for cyclic effects. So we've talked about that a little bit. Pressure cycling, consider Appendix K for pressure piping. So this Appendix F is sort of like a roadmap to sort of look at cyclic different issues like cyclic effects, and sort of points you to the relevant sections. So there's also a thermal fatigue at mixing points you should consider. This is something that's outside of the criterion. So if you have a lot of thermal mixing, then you can get fatigue. Thermal fatigues, continuous heating and cooling, and severe cyclic loading conditions and cycling conditions that should be considered. So they go on and they say, severe conditions, there are many cycling in high ranges. So they can repeat that again, and they talk about many cycles. So when the stress and range factor is F is less than FM, and this was discussed earlier as well. Then we have a high stress range calculation. Stress range approaches the allowable stress range. And we continue with the Appendix X warnings. And we say warnings, there's also have warnings about small branch connections, because small branch connections can vibrate and shake if they're not reinforced with gusseting. And this is, there's a lot of industry cases of that. So they say, there's several articles or literature written about the warnings of small branch connections, and one of them, the ASME quotes as guidelines for the avoidance of vibration-induced fatigue failure in process pipe work in the Energy Institute. And a lot of the client specs, by the way, have incorporated these issues, and they have standard drawings for gusseting for connections. And design guideline for small diameter branch connections is published by the Gas Machinery and Research Institute, Council. So Appendix W talks about high fatigue assessment in piping systems. So high fatigue assessment of piping systems. So we'll continue here. So it's applicable to cycles where you've got over 100,000 cycles and greater than 3 KSI of stress in your part. And they may be due to thermal expansion, anchor motion, vibration, inertial loads, and wave motion or other sources. It does not include pressure cycling, referred to Chapter 9, or ASME Boiler Pressure Vessel Code, Section 8, Division 2. Now we can continue on to a summary of Appendix X, and this is very similar to, described in other codes, but the metallic expansion joints, if you go to 302.1.3 fatigue analysis effects. So basically they say, it has to be done to ASME standards, and in there's requirements to ensure that there's, you're designing to prevent a fatigue. And then fatigue requirements is required per ASME standard, Appendix F. And then there's the fatigue correction factor, 75% shall be used.
I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.